Hi, my name Lili Zhang, and I'm an undergraduate student at Hainan University. On behalf of my co-authors, I'd like to present our paper titled Partiality and Misconception, Investigating Cultural Representativeness in Text-to-Image Models. Firstly, I will share our research motivation. Text-to-image models, commonly abbreviated as T2I, have gained increasing popularity in recent years. Notable examples include DALL-E v2 and Stable Diffusion. These models are being embraced as valuable tools for creative expression. By leveraging simple text prompts, users can generate high-definition and realistic images. However, T2I models undergo training using data, and if the data samples contain biases, the models can subtly absorb these biases during the learning process. This can lead to the assimilation and potential amplification of latent biases within the model. Previous research efforts have primarily focused on examining biases related to race and gender, leaving cultural representativeness largely unexplored. For instance, in the case of T2I models generating images depicting classic Belgian food, such as stoem, the comparison between the generated images and authentic ones reveals significant discrepancies. Consider the potential misinformation of generated images, like those of stoem on social media platforms. This could exacerbate partiality and misconception surrounding the dish. Hence, our research endeavors to explore whether the generated content can fairly and accurately reflect global cultures. Next, I will outline our research strategy. Using three prevailing T2I models, Stable Diffusion v1.5, v2.1, and DALL-E v2, we investigated cultural representativeness through four aspects: distribution, diversity, patchwork, and fidelity. The key to investigation is the introduction of two cultural attributes. The first one is cultural clusters. Previous work often simply selected representatives by geography, for example, choosing 3 countries on each continent, which does not fully represent global cultures. Building upon an extension research of the globe study, we have selected 3 representative countries from 10 clusters. This allows for a better reflection of the general characteristics of the clusters. For example, China, Japan, and Vietnam are chosen to represent the Confucian cluster. Another key attribute is cultural subjects. Drawing upon E.B. Tyler's definition of culture, we categorize culture into 2 types: material culture and non-material culture, to ensure comprehensive investigation. For material culture, we selected 5 subjects: apparel, food, architecture, artwork, and handicraft. On the non-material side, we chose 4 subjects: mythical figures, performance, game activities, and festival activities. During the data collection process, we established 2 datasets: the generated dataset and the UCOG dataset, utilizing 2 types of prompts: neutral prompts with no regional constraints, and expanded prompts specifying cultural subjects and country names. We generated a total of 81,000 images. Additionally, we invited the expertise of 2 cultural domain specialists who identified 752 cultural objects across 30 representative countries spanning 10 cultural clusters. For instance, within the Southeast Asian cluster, we selected 3 cultural objects, Pancharathas, Badami Caves, and Gopuram, as representatives of Indian architecture. According to the specific cultural object prompts, an additional 112,700 images were generated, and in the UCOG dataset, there are 37,600 authentic cultural object images included. Next, let's delve into the methodology used to evaluate bias in the model across 4 aspects. To analyze the distributional features of images generated with neutral prompts, we adopt a classification approach to determine the corresponding regions represented by these images. Given the challenge of insufficient samples and poor performance of classifying models, we employ transfer learning using pre-trained models. Specifically, we leverage 2 prevailing architectures in deep learning: convolutional neural networks, CNNs, and vision transformers. From each category, we select 2 models, ResNet 50Phi2 and VTB 16. Firstly, the images generated with expanded prompts across 9 cultural subjects were individually learned, allowing us to train classifiers for each subject. The images generated with neutral prompts without specifying country were then fed into the classifier, and then the distributional preferences of each cultural subject for different regions were obtained. For the images generated with expanded prompts through Venn score and manual evaluation, we discovered that their diversity is uneven and some cultural subjects exhibit a patchwork phenomenon. We opted for the Venn score, which is highly interpretable and doesn't necessitate training data to analyze diversity. Through manual recognition, we counted the number of occurrences of patchwork when specifying country and subject. By analyzing the bias in distribution, diversity, and patchwork across specific countries or cultural clusters, we can assess the fairness of the T2I model. Now, how do we assess the accuracy of the model? We can do this by comparing the similarity between generated images and authentic images, namely fidelity. For image generation models, most works use automated tests to validate the fidelity of their models, such as FID and KID, but it is criticized for inadequate assessment of non-ImageNet datasets and being inconsistent with human senses. So, in addition to classical FID and KID scores, we integrated human scoring. To ensure scoring quality, we conducted cultural training and qualification tests for annotators. By comparing the dataset generated from cultural object prompts with the authentic UCOG dataset, we can calculate FID and KID scores. Using authentic UCOG images as a reference and scoring the generated images on a 5-point Likert scale, we can obtain the human score. Next, I will present detailed results, starting with the distribution analysis. We calculated the probability distribution of various cultural clusters across 9 subjects and summarized them as averages. The table on the right illustrates the overall classification results obtained from the VIT and ResNet classifiers for the unspecified generated images. Due to the different features extracted from the pre-training of the 2 models, there are differences in the results of the classification after training. To analyze further which countries are being overrepresented and which are being neglected, we compared the mean value of the distribution result against the population and GDP share of the corresponding cultural cluster in 2021 in this figure. If a T2I model is fair, the distribution results of images generated with neutral prompts should align with the demographic composition of the world. For cultural clusters where the model's distribution proportion is lower than the actual population proportion, we've marked them with the deepest lines. Clearly, the SE Asian and Afric clusters are overlooked most, with an average distribution share across the 3 T2I models standing at only 16.5% and 47% of their respective actual populations. The farther the brown population share is from the red GDP share to the y-axis, which means the lower the GDP per capita is, and the lower the distribution proportion of the clusters in the generated images. This implies that the model is more partial to countries with advanced levels of economic development, and such an unfairness has the potential to further exacerbate the underrepresentation of disadvantaged countries. We visualize the Venn scores of each country and subject using heat maps, where the larger the chromatic shift, the greater the fluctuation of the Venn scores. Some countries' Venn scores for the same subject vary quite a bit. For example, in 3 models, Iran's architecture scores low in red, while Denmark scores high in blue. These are examples of images evaluated with low Venn scores, which appear very similar. For some countries lacking variable data, it raises the problem of homogeneity, which may further contribute to stereotypes about them. The 3 figures show the number of occurrences of each collocation within 50 images generated by each expanded prompt in the form of a heat map. Among the 3 models, apparel and performance have the most serious situation. For Stable Diffusion V 1.5 and Canada, the apparel occurs patchwork up to 47 times. The figure illustrates examples of images that are accessed to represent a patchwork. When the T2I model is unable to understand the subject qualifier together with the region qualifier, it will show a case of patchwork by simply adding some independent elements, such as the national flag, to the subject. The table shows the results of FID, KID, and human evaluation scores calculated in the 9 cultural subjects. The lower the FID and KID and the higher the human evaluation score, the more similar the generated images are to the authentic images. The trends of FID and KID are generally consistent, except for in festival activity, where the FID of Stable Diffusion v2 suddenly declines dramatically and significantly outperforms the other two models. This may be caused by the failure of the images in this dataset to conform to the normal distribution assumed by FID. For human evaluation, we assessed annotator agreement using the intra-class correlation coefficient and achieved high agreement up to 0.98 among the raters. Therefore, we opted to utilize the human evaluation results to label the accuracy of cultural objects. The proportions of cultural objects with human scores lower than 3, indicating a failure to achieve even so-so or okay similarity, in Stable Diffusion v1.5, v2.1, and DALL-E v2 are 56.5, 52.7, and 43.8% respectively. This indicates that over half of the cultural objects are misrepresented. These are some examples with human scores below 2, indicating they are fairly dissimilar. For instance, in the top right corner, drop, a type of food from the Netherlands, is associated with water droplets. Although some words are close in amending distance, they are in fact completely different items, and if the model understands them incorrectly, it will generate fully inconsistent images, which further amplifies the risk of transmitting misleading information about cultural objects. Okay, now let's move on to the conclusion. Our research framework diagram is shown on the right, and the contributions of our research can be summarized as follows. Firstly, we introduced attributes of cultural clusters and subjects for analyzing cultural representativeness, providing a fresh perspective and interdisciplinary approach to multimodal bias analysis in cultural representativeness. Secondly, through the analysis of a vast number of generated and authentic images, our research is the first comprehensive exploration of T2I models' performance in cultural representativeness, uncovering biases in distribution, diversity, patchwork, and fidelity. Thirdly, our proposal of the UCOG dataset not only serves as a benchmark for T2I models, but also supports the training of other visual models. Our datasets are available on GitHub, and please refer to our paper for further details. We are grateful for your attention and support throughout this journey. Thank you.